V2 with the help of using nodal analysis. I hope so. Visibility is clear. I hope so. Visibility is clear. And sound. So please check sound. Hello. Hello. Visibility is clear. Hello. Visibility is clear. Now. So we have focused on how can determine. Our motto determine V1 and V2 with the help of nodal analysis. So first of all, what about nodal analysis? Nodal analysis say that is the application of KCL. This one is the application of KCL. So how can we utilize? First step, decide branch current of, okay. So first of all, mention branch current. After that, mention node voltages, define node. And third step, one node take ductum node. Fourth stage, apply KCL at nodes. After that, equate equation. Okay, clear or not? So first step, we have focus on one by one. Here branch current is given 5 ampere upward direction. What about branch current? No, not given, so assume here I1. What about branch current? Here I2. And what about branch current here? That is I3. Okay, so all branch current are that one, that one, that one, that one. This branch current already given 2 ampere. So after that, next step, node voltage. Here that one node already given, and that node, that is suppose that is V3 and that is V4. Okay, now next target is one node as a ductum, consider a ductum node. So one node consider a ductum node means if this one and this one, suppose that one, if this one is a 0 voltage, so that one is also 0. Why? Because of no voltage drop between these two. No any source connected, no any resistance, no any current source, voltage source available. That's why that point and that point are same potential. Clear? After that, if these two are same voltages, now next target is apply KCL at nodes. Apply KCL at that node. After that, apply KCL at that node. Okay, clear or not? Before apply KCL, if you see very carefully, what is the relation between V1 and V2? And that is 8 volt. So if any doubt, then make that one here minus, here plus, that is how much? 8 volt. And here V1 and here V2. So what is the meaning of that one? Basically, you can represent minus plus, that is 8 volt, and that one, basically, what is the meaning of that one? With respect to ground, that is V1 and that is V2. If apply KVL in this loop, we got minus, first word minus, here minus 8 plus V2, this be equal to 0. So what is the relation between V1 and V2? V2 minus V1, this be equal to how much? 8. That is equation number 1. So you can write now here V2 minus V1, this be equal to 8. That is equation number 1. If anyone faced doubt in any step, then okay, if anyone faced doubt, I think sound is clear. I think sound is clear, visibility is clear. If anyone faced the visibility problem or sound problem, then comment it. I will take it again. Okay, rearrange. So first of all, clear or not? What is the relation between V1 and V2? So I have no idea about, suppose that you have no idea about what is the V1, what is the relation between V1 and V2. But I know that, what is the meaning of that one? If this one is given, represent that one. After that, what is the meaning of that one? Basically this one, plus minus, here plus minus with respect to ground. So after that apply KVL, then we got relation V2 minus V1, this is equal to 8 volt. It means if V2 minus V1, V2 minus V1, this is initial voltage and that is final voltage. So initial minus final, if any voltage source available, then if going on here to here, so which what polarity, that is plus, so written plus. Otherwise you can follow that method. Okay, so now if you make here, then I will go apply KCL. After that apply KCL at that node. Incoming current, how much? 5 ampere. Outgoing current, I1 plus I3. What about I1? I1 is basically V1 minus 0 divided by how much? 10. And what about I3? I3, no resistance given, so simply written I3, and that is 5. Okay, clear? Or you can say that I3 is written 5 minus V1 by 10, that is equation number 1. Now next target, apply KCL at that node. I3, incoming current at that node is I3 plus I2, sorry 2 ampere. I3 plus 2, this is equal to how much? I2. And what about I2? So I3 is written, I2 is written how much? V2 minus 0, V2 minus 0 divided by 5, and this one is going on. So V2 by 5 minus 2. So we written here V2 minus 5 minus 2. That value put here. So you can 5 minus V1 divided by 10 is written as V2 by 5 minus 2. Okay. Now multiply by 10 in both sides, then we got 50 minus V1, this is equal to 2V2 minus 20. So 2V2 plus V1, this is equal to 70, equation number 2. Okay. Now here written V2 minus V1, I have already done. Equation number 1, both are adding, then we got how much? 3V2, this is equal to 78. So V2 is how much? 3 1 ja 3. Okay. 3 2 ja 6. 3 2 ja 6 and 3 5 ja 15, 3 6 ja 26 volt. V2 is how much? 26 volt. If that value put here, then we got V1. V1 is how much? That is 26. 26 minus V1, this is equal to 8. So V1 is 26 minus 8, that is how much? 18 volt. So V1 is 18 volt and V2 is 26 volt. Okay. I hope so. If anyone faced doubt in any in any step, then tell me, I will discuss again. If anyone faced doubt, then tell me, I will discuss again. If anyone faced doubt, then tell me, I will discuss again. Okay, I hope so. All doubt are all clear. Otherwise, I will explain again. Okay, I will explain again. Wait, I will explain again. Our motto determine V1 and V2 with the help of, in question mention, with the help of nodal analysis. If you say, if a question mention with the help of nodal, so wait. I think visibility is clear. Wait. I think I hope so. Now, I think visibility is clear. Okay. Now, our motto determine V1 and V2 with the help of nodal analysis. Question mentioned with the help of nodal analysis. So, always using nodal analysis, not other method. Nodal analysis say first step is, first of all decide branch current. So, that one, and that one. This current are already given. So, we have assumed here I1, here I3, here I2. Next step say nodal analysis decide node voltages, that voltage, and that voltages. And next step, one node as a take reference node or your ductum node. So that one taken ductum node, that is 0 voltage, Okay, if this one is 0 voltage, that is also 0. Why? Because no any source or any impedance or whatever, and no any connection between these two. So these are same potential. So if this one is 0, that is also 0. After that, next target is V2 minus V1, this is equal to 8 volt. So written here. Already discussed why V2 minus V1 this is equal to 8 volt. Already discussed. Okay. Now next step, after that apply KCL at that node, and after that node. Apply KCL that node. Incoming current 5 ampere, outgoing current I1 and I3. So 5 this is equal to I1 plus I3. What about I1? I1 is V1 minus 0 divided by 10. And what about I3? I3 is written simply like that one. So after solving this, we got I3 is like that one. Next target, apply KCL at that node. Incoming current I3, outgoing and 2. So I3 plus 2 written like that one. Outgoing current 2, I2. After that, what about I3 and V2? I2 is written V2 minus 0 divided by how much resistance? 5. So written 5. And this one is going on here. So we got like that one. These two are same. So equating, then we got, finally we got 2V1 minus, sorry. Look here. That one, this one is basically V2. Silly mistake. And that one is basically V2. Okay. So after solving, they got 2V2 plus V1, this is equal to 70. And this one, V2 minus V1, this is equal to 8. After solving these two, we got V2 is 26 volt. And that value put here, then we got V1 is 18 volt. I hope so. All doubt are clear. I hope so. All doubt are clear. If anyone face doubt, then tell me again. I will discuss again. If anyone face, then comment it. Anyone face doubt, then comment it. Sir, I face doubt at that step. Please explain. Need more explanation. Okay. So I will discuss. Okay. Otherwise, I will take another problem. I hope so. Okay. Now we have considered another problem also. Now we have considered another problem also. Okay. Okay. These three resistance, and here 20 plus 24 volt, here 24 volt, and that one is, and here current source, and after that here a 20 ohm. Okay. And that is 40 ohm. This one is 40 ohm, and that is 10 ohm, and and here 20 ohm, and that one is 30 ohm, and that one is 20 ohm. Okay. Our motto determine I1, and that one is 5 ampere, and that one is I2. Okay. Our motto determine I1 and I2. with the help of nodal analysis, with the help of nodal analysis. Okay, with the help of nodal analysis, how can do? Using our motto, determine I1 and I2 using nodal analysis. If question mention with the help of nodal analysis, so you can do always nodal analysis, not other method. Never use other method, otherwise your marks is cut down. Okay. Now, so how can do it? First of all, so it is clear what is our motto, determine I1 and I2. So according to nodal analysis say, what about nodal analysis say? Nodal analysis say, whatever first step. First step is decide branch current. First of all, decide branch current. Okay, that branch current is given. That branch current is given. But what about that branch? Not given. So we have considered that is I3. And what about branch not given? So we have assumed that is I4. Clear? That is I4. Clear? Our motto, we have focus on I1 and I2. Next target, node voltage. Second step, nodal analysis say, second step, follow node voltage. Decide first of all node decide. That is that node, and that node. At least at least 3 branches connected at any junction, that's called node. Okay. So if this one is V1 and that is V2 and that one is V3 and that is V4. Okay, that is V4. But no any source or any resistance connected between these two. So these two node has the same potential. Okay. So you can say that that is V3, this equal to V4. Now third step say nodal analysis. One node take ductum node. Whatever we assume here, or here, but we have comfortable with that one. So we have considered this one is a ductum node. It means 0 voltage. So that one is also 0 voltage. Why? Because of these two voltage are same. No any impedance, no any resistance, no any source connected between these two. That's why same potential. If this one is 0 voltage, that is also 0 voltage. After that, if you see very carefully, how can do I1, I2? How can determine I1, I2, I3? Now next step, 4 step. First step say decide branch current. After that, second step say node voltage. After third step, decide one node as a ductum node. So we have considered that is a ductum node, means 0 voltages. Now fourth step, apply KCL. Okay, at that node and that node. So written here, apply KCL at a node, at nodes V1 and V2. V1 and V2. Now incoming current at that node, incoming current I3, outgoing current I1 plus I4. Okay, clear or not? Now apply KCL at that node, incoming current I4 and plus I5 ampere, this is equal to I2. What about KCL? Algebraic sum of current at any node is 0, or you can say that sum of incoming current, this is equal to sum of outgoing current. Okay, so that apply here, that's why apply here. Clear or not? If anyone face any doubt corresponding to in my any step, then tell me, I will discuss again. So I hope so clear. Sum of sum of that node, sum of incoming current, this equal to sum of outgoing. Sum of incoming current, simple, only one current is incoming, so I3. Outgoing current I1 and I4, so written here. Now that node you have considered incoming current I4 and I5 5 ampere, outgoing is I2. So I4 plus I5, this sorry I4 plus 5 this will equal to I2. Clear or not? Now next step. Now next step is, what about I3? I3 is written, that's 0 voltage. So 0 minus V1, current leave from positive terminal, so plus 24, divided by how much? 10. What about I1? V1 minus 0, V1 minus 0 divided by 40. What about I4? I4 is written simply V1 minus V2 divided by how much? 20. Okay. Now multiply by 40, multiply by 4 in both sides. Then how much? That is 4 into, we got 4V1. Okay, because multiply 40 means 40 divided by 10, that is 4 into V1 plus, that is how much? 6, and that is 96. Okay, and what about that value? V1. And if you multiply by 4 by 40 by 20, that is 2 into V1 minus 2V2. Clear or not? If you multiply by those both sides 40. Okay, so 0 by 40 by 10, that is 4. Okay, clear or not? If anyone faced out, then tell me, I will explain again. After that we got like that one. Now V1 plus 2V1, that is 3, and this one is going on here in that side. Then we got 96, this will equal to 3 plus 4, that is 7V1 minus 2V2. So written here 7V1 minus 2V2, this will equal to 96. That is equation number 1. If okay, that is equation number 1. Again recheck. Maybe my side also wrong. Maybe my side also wrong. Okay, so recheck here. I3 is how much? 0 minus V1 and current leave from positive terminal, so plus 24 divided by how much resistance in between in branch, that is 10. So written 10. So 0 minus V1 plus 24 divided by 10. After that I1 is V1 minus 0 divided by 40, right? V1 minus V2 divided by 20, right? After that multiply by 4, 40, then in both sides, then we got how much? Minus 4V1 plus 96. Okay, and that one is V1 simply, and that is 2V1 minus 2V2. After solving we got like that one. That is equation number 1. If anyone faced out corresponding to any step, then tell me, I will discuss again. Now next step we are going on here, so I will remove. Okay, so due to space problem, that's why I4 is written V1 minus V2 divided by 20, this big plus 5, this be equal to, what about I2? I2 is how much? V2 minus 0, V2 minus 0 divided by sum of these two resistance, V2 minus 0, sum of these two resistance, 30 plus 20, that is 50. So written 50. Okay, now after that how can solve? If multiply by 100, okay, in both side, then how much? 100 by 20, that is 5V1. So 5V1 minus 5V2 plus 500, this will equal to 100 by 20, that is how much? 100 by 50, that is 2V2. This will equal to 2V2. After that 7V2 minus 5V1, this will equal to 500. That is equation number 2. Okay, I hope so clear. Now 7v1 minus 2v2, this will equal to 96. So if you v2, what about v1 from here? So first of all, recheck again. This one is going on here. So 5 plus 2, that is 7, minus 5v1 and minus 5v1, this will equal to 500. Okay, and that one is 7v1 minus 2v2, this will equal to 96. Our target is determine v1 and v2. Okay, so if put v2 is how much? 500 plus 5v1 divided by 7 in equation number 1. Okay, in equation number 1. Then we got 7v1 minus 2, 500 plus 5v1 divided by 7, this will be equal to 96. Okay, after that we got 49 v1 minus 2 into 500, that is 1000, minus 10 v1, this will be equal to 7 into 96. Clear or not? If anyone faced doubt, then tell me, I will discuss again. Okay, after that I will remove that one. I will remove that one. Okay, that is 49 minus v1, 49 minus 10, that is 39. Okay, this will equal to 7 into 96 plus 1000. So what about v1? 1000 plus 7, 2, and that is 4, 67. That is 1672 divided by 39. So what about that value? What about that value? Using calculator, with the help of calci, you can do. With the help of calci calculator, what about that value? That is 1672, okay, divided by 39. That is how much? 42 point, that is 42 point, 42 point, how much? 87 volt. Now that value put in equation number 1. Then we got v2. So 2v2, this will equal to 7 into v1 is how much? 87 minus 96. Then what about that value? Into 7 minus 96 divided by 2. Then how much? So finally v2 is how much? 102.05 volt. So v1 and v2 we got like that one. So what about I1? I1 is how much? I1 is v1 minus 0 divided by 40. So v1 is 42,487 divided by 40. That is 1 point, that is 42.87 divided by 40. That is how much? 1.07. 1.07 ampere. And what about I2? I2 is how much? I2 is how much? V2 divided by 50. V2 divided by 50. And V2 is how much? 102.05 divided by 50. That is 102.05 divided by 50. That is 2.041. Okay. That is how much? So first of all, make it. If anyone phased out, then comment it. I will discuss again. If anyone phased out, then I will discuss again. Okay. If anyone phased out, then I will discuss again. So I1 is 1.07, I2 is 2.041. So I1 clear? I hope so clear. Now I will take another problem also. So I hope so make it. After that I will take another problem. Now next problem is, I will take another problem. A resistance, in another resistance like that one, a resistance like that one, a voltage source connected. Here 8 ohm and here minus plus and here plus minus, and here a current source given like that one. Okay, and that one is 40 ohm, sorry 40 volt, that is 40 volt, and that one is 1 ohm. Our motto determine V naught, and that one is 4 ohm, and that is 20 volt, and that one is 8 ohm, and that one is 2 ohm. And what about current in current source? That is how much? 5 ampere. Our motto determine V naught using nodal analysis. Using nodal analysis. First of all, everyone can try, then I will do. First of all, everyone can try, then I will do. Okay? First of all, everyone can try, then I will do. I hope so. If anyone face any doubt in any step, if you not understand what any problem, then comment it. I will discuss again. Our motto, determine V naught. So first of all, what is our motto? Our motto, determine V naught using nodal analysis. If question mention using nodal analysis, so always using nodal analysis, not using another method. Okay, so be carefully. Now, how can do? First of all, that one remove, and here V naught. Okay. Now, how can you determine? First of all, nodal analysis say, first step say branch. First of all, decide branch current. What about branch current here? Simply written I1. What about branch current here? That is I2. What about branch current here? That is I3 simply. And what about branch current here? That is I4. And that branch current already given. Next target is decide node voltage. Next target is decide node voltage. So that one is V1 and here V2 and that one is ductum node. So V3. And now after that one node as a ductum node. So we have taken that one is a ductum node 0 volt. Next step, fourth step say nodal analysis, apply KCL given at given node. Okay, apply KCL at given node. So what about first step? First step say nodal analysis, decide branch current. Second step, decide node voltage. Third step, one node as take ductum node. Fourth step, apply KCL at given nodes. Okay, after that we got equation and solve and find the answer. Okay, so apply KCL here and apply KCL here. That is two nodes. So first of all, apply KCL at node, at nodes, not node, nodes. Why? Because two nodes using here. So V1 and V2. V1 and V2. V1 and V2. So what about KCL? KCL say algebraic sum of current at any node is 0, or you can say that another word, sum of incoming current this equal to sum of outgoing. No any incoming current here. Odd current are outgoing. So I1, I2 and 5. So written here I1 plus I2 plus 5 this is equal to 0. Okay. And now here look here, incoming current at that node 5 and I2. So 5 and I2 this is equal to outgoing I3 plus I4. Okay. What about I1? I1 is V1 minus 0. Currently from minus terminal, so minus 40 divided by 1. What about I2? I2 is V1 minus V2 divided by 2 plus 5 is equal to 0. Okay, multiply by 2 in both sides, then 2V1 minus 80 V1 minus V2 plus 10 this is equal to 0. 3V1 minus V2 and that is 70. So 70 equation number 1. If anyone face any doubt, then comment it. I will discuss again. If anyone face any doubt, then I will discuss again. So 3V1 minus V2 this is equal to 70. Now next one, if you see here written 5. What about I2? I2 is V1 minus V2. V1 minus V2 divided by 2. This is equal to I3. I3 is V2 minus 0. V2 minus 0 divided by 4. plus what about I4? I4 is written as V2 minus 0. Current leave from positive terminal, so plus 20 divided by how much? 8. Okay. I think visibility is clear. I hope so. Visibility is clear. If anyone face any doubt corresponding to any step, then tell me. I will explain again. Okay. If you understand everything, then comment it. Sir, I will understand. This question is easy or hard. Your valuable feedback is very important for me. If you give me valuable feedback, then I will very happy, because I will improve. Okay. Where is 0 in equation number 1? After solving, in which equation, dear? That equation, that question, or previous? I1 plus I2, all incoming current here. That's why all current, no any incoming current, all current are outgoing. So I1, I2 and 5, this will equal to here outgoing current, no any incoming current at that node, that's why 0. Okay. Now look here. I hope so clear. What are you saying? And after solving these, and we got that one. Now look, 5 I2 is how much? Recheck again, V1 minus V2 divided by 2. And I3 is how much? V2 minus 0 divided by 4. Okay. And that one V2 minus 0, currently from 20 positive, so plus divided by 8. Okay. Now after that, if multiply by 8 in both sides, then how much? 5 into 8. 5 into 8, that is how much? 40 plus 4v1, because multiply by 8, 8 by 2, that is 4. So 4v1 minus 4v2, it is equal to 8 by 4, that is 2v2 plus v2 minus v2 plus 20. Okay. Now 40 minus 20, that is 20. This is equal to 3 plus 4, that is 7v2 minus 4v1. Okay. So that is equation number 2. What about V2? V2 is written 3v1 minus 70. If that value we put here, then we got 20, this is equal to 7v2 means 3v1 minus 70 minus 4v1. So 20, this is equal to 21v1 minus 4v1. Okay. That is 17. After that we got 17v1, this is equal to, if this one is going on here, then we got how much? 4, 5, wait, that is 510. So V1 is how much? 30 volt. Okay. 310 divided by 17, that is how much? 30 volt. So what about V2? If that value put in which equation? Equation number 1. Then 3 and 3, that is 90 minus V2, this is equal to 70. So V2 is 20 volt. Okay. So what about V0? V0 basically V2. If any doubt, then right now here. What about I3? I3 is how much? V2 minus 0 divided by 4. Okay. And what about V2? V0? V0 basically 4 into I3. So 4 into I3, V2 by 4. Though we got V2. So V2 is how much? Finally, we got 20 volt. Is the right answer. Make it. V2 is finally 20 volt. Okay. If anyone face doubt in any step, then tell me. I will discuss again. Okay. That is 20 volt. So first of all, make it everyone. After that, I will take another problem. If anyone face any doubt corresponding to any step, then tell me. I will discuss again. If anyone face any doubt corresponding to any step, then tell me. I will discuss again. Simply, I will explain again. Repeat. Our motto: determine V naught. Okay, with the help of using nodal analysis. With the help of using nodal analysis. So how can do? How can use nodal analysis? Nodal analysis say first of all decide branch current. Okay. So that's why we have to consider here I1, I2, I3 and I4. After that, decide node voltage. Here V1, here V2, after that and V3. And next step, third step say one node take ductum node, means that one we have considered zero voltages. That is zero voltages. Now next step, apply KCL at nodes, given nodes. Means apply here KCL, and if required then apply KCL also here. Okay, as per requirement. So apply KCL at node V1 and V2. So written incoming current, no incoming current, all current are outgoing, that one and that one is outgoing. So I1 plus I2 plus 5 is equal to 0. Now here that node incoming current 5 ampere and I2, this is equal to outgoing current, this one plus this one, written like that one. After that, what about I1? I1 means V1 minus 0, current leave from negative terminal, so minus 40 divided by how much resistance in this branch? 1 ohm. After that, I2. I2 is written V1 minus V2 divided by 2 plus 5, this equal to, after solving this one, we got equation number 1. Now next target, what about I2? I2 is V1 minus V2 divided by 2 written. And what about I3? I3 is V2 minus 0 divided by 4. That's why written here. And after that, what about I4? I4 is V2 minus 0 current leave from positive terminal. So plus 20 divided by how much resistance in this branch? That is 8. After solving, we got equation number 2. Equation number 1 and equation number 2. After solving, we got V1 is 30 volt and V2 is 20 volt. But our target is that voltage. So V0 is written 4 into I3, current I3. I3 is V2 by 4. So put here, then V0 this is equal to V2. So V2 is 20 volt is the right answer. If anyone face any doubt, then comment it. I will discuss again. If you face any doubt, so kindly your feedback is very important for me. If you give me valuable feedback, then I will improve. Okay. If you feel very tough question, then comment it. If you feel easy question, then also comment. Sir, I feel okay. So now next one, So the next problem is, okay, so now next problem is a current source, sorry, here a current source like that one, another current source, independent current source, and here a resistance, another resistance connected like that one. Okay, that is 2 ohm, and that is 8 ohm, that is 4 ampere, that is 2ix, that is 4 ohm, and that is 1 ohm. Our motto determine Ix, and here also Ix given. Okay, our motto determine Ix using nodal analysis. Nodal analysis. So first of all, everyone can try, then I will do. Everyone can try, then I will do. Okay. First of all, everyone can try, then I will do. Okay. First of all, everyone can try, then I will do. Okay. How can you use? So now, if you're using nodal analysis, so always follow given 4 steps. First one, branch current. Branch current, here I1, here I2, here I3. After that, next target is, what about next target? Next target is node voltages. Beside node voltage, here V1, here V2, here V3, and here V4. Third step, one node take ductum node. Ductum node means 0 voltages. Otherwise, you can also choose 10 volt or 5 volt, whatever. But if you select 0 voltage, then your circuit, or you can say your equation, is more easy. Okay. Otherwise, if you consider 10 voltage, then we got 10, corresponding to answer, we got same, no problem. Okay. If you got select, for simplicity point of view, we have select 0 voltage. Okay. Fourth step, apply KCL at given nodes. How many nodes? If requirement, then apply KCL here, here, here. So you right now here apply KCL at nodes V1, V2, and V3. Here incoming current, no incoming current, outgoing current, here Ix plus 4 plus I1 is equal to 0. Okay. So Ix is V1 minus 0 divided by 8 plus 4. What about I1? V1 minus V3, V1 minus V3 divided by how much? 1 is equal to 0. Okay. So 8, then 9V1 minus 8V3 this is equal to minus 4. Equation number 1. After that, apply KCL at that node. 4 ampere, this is equal to I2 plus 2ix. Okay. What about Ix? And what about I2? 4, this is equal to I2 is written V2 minus 0 divided by 2, and 2 Ix is how much? V1 by 8. V1 by 8. Okay, if multiply by, that is also written 1 by 4. So multiply by 4 in both sides, then 16 this is equal to 4 by 2, that is 2V1, and this is V1, sorry, V2, and that is V1. Equation number 2. Okay. Now apply KCL at that node. Incoming current I1, incoming current I1 plus how much? 2Ix. This is equal to I3. Okay. This is equal to I3. Clear or not? That is I3. I1 is how much? V1 minus V3, and that is 2. Ix is how much? V1 by 8. And what about I3? I3 is V3 minus 0 divided by 4. Okay. Now multiply, and that is 4. So if multiply 4 in both sides, then we got how much? 4V1 plus 1, that is 5V1. 5V1, okay, minus 4V3, okay, this is equal to V3. So that is V3. It means V1 this is equal to V3 after solving. So that value put here, then we got finally, if V1, V3 this is equal to V1, so 9V1 minus 8V1, that is simply V1 this is equal to minus 4. Okay. And so V1 we got minus 4. So what about Ix? Ix is V1 by 8. V1 by 8 means minus 4 divided by 8, that is minus 0.5 ampere. Is the right answer. Make it. That is 32. This one is 32. So recheck again. Minus 32, and if that value put here, then we got that is minus 32. Okay. So if that value put here, minus 32 divided by 8, that is minus 4 ampere is the right answer. Make it. Okay. So final silly mistake here. Okay. If we got Vx is minus 4 ampere. If anyone faced out, then comment it. I will discuss again. If anyone faced out in any step, then I will discuss again. Okay. If anyone faced out in any step, then comment it. I will discuss again. So first of all make it now I will explain again. Recheck. First of all, our motto determine Ix, that current. So with the help of using nodal analysis, So nodal analysis say 4 step. First step say decide branch current. So that's why we have considered that current, that branch current I2, I3 and I1. Next step, node voltages V1, V2, V3 and that is V4. Next step, one node take as a ductum node. That's why we have considered that one is a ductum node, that is 0 voltage. Fourth step, apply KCL at given nodes. Apply KCL given nodes. If requirement, then apply KCL here, here, here. Okay. Now next step. So after that solve. We got equation and equating this given equation. We got the answer. Okay. So apply KCL at node V1, V2, V3. So here incoming current, no incoming current, all current are outgoing. So algebraic sum of current at any node is equal to 0, that is KCL, or you can say that sum of incoming current is equal to sum of outgoing current. Sum of incoming current is equal to sum of outgoing current. Clear? So no any incoming current, so all current are outgoing. So Ix plus 4 this plus I1 this equal to 0. I1 is written, sorry, Ix is written V1 minus 0 divided by how much? 8. And what about I1? I1 is V1 minus V3 divided by 1. After solving, we got like that one. After that, apply KVL, KCL, KVL, and here 4 ampere this is equal to I2 plus KCL, and 4 ampere incoming current 4 this is equal to I2 plus 2Ix. Then we got how much? Equation number 2. Now third step, apply KCL here. Incoming current 2Ix plus I1 this is equal to I3. Like that one. Put this value, we got like that one. Okay. After that, after solving this one, we got how much? V1 this is equal to V3, this is equal to V1 this is equal to V3. Put here, then we got minus 32. And Ix is how much? V1 by 8. So we got minus 4 ampere is the right answer. If anyone faces any doubt corresponding to any step for nodal analysis, then comment it. Sir, I face the doubt. You have considered hard problem or easy problem. If you want to more easy problem or if you want to more hard problem, then I will take an next class hard problem or easy problem according to your understanding. Okay. If you're not understanding, also comment, sir, I will not understand. What are you saying is very difficult to me. If you more explanation, then I will next class I will improve. Okay. So thank you very much. Today class is over. Okay. Thank you for joining. Thank you very much, sir. Thank you, everyone. Thank you. So